So if you want to study in detail about this particular subject, you can refer Modern Control System. So reference Modern Control System by Ogata. So this is one of the best book for studying about control engineering. So Modern Control System by Ogata. So here you will have both classical theory as well as modern theory, Ogata. Then we can have Control Systems by B.C. Koo. Control Systems by B.C. Koo. So this is another most important book for this particular subject, Control Systems by B.C. Koo. Then if you want to do numerical problems, objective type questions, you can refer Shom series. Shom series, Control Systems. So this is going to be useful for objective type questions and numericals. So those who are preparing for competitive examination, those who are preparing for GATE examination, so PSC exam or central government public service exam, so they can refer, make use of all these books. So Shom series, Control System, objective type questions. So in every subject you have Shom series available, which is the most useful book for preparing for objective type questions, because almost all competitive exams are objective type. So you can use Shom series. Upper Shom series, Control Systems, objective type questions. So these are the references. So classifications of control system. So we started with the classifications of control systems. So control systems can be mainly classified into, one, open loop control, closed loop control or feedback control, closed loop control. So we have discussed some of the advantages and disadvantages. So further classifications of control systems are: 1. Linear control or linear control system, non-linear control system. Third one, time invariant control, time invariant. So we will discuss each of these terms. Time invariant control, time varying control, single input, single output control, single input, single output control. So that is called SISO control, SISO, single input, single output system. Multiple input, multiple output, multiple input, multiple output control. So multiple input, multiple output control. So that is MIMO control. MIMO control. Then further classifications are, so we will not call it as 7. So we will call it as A. Servo mechanisms, regulator mechanisms, electrical control, electronic control, mechanical control, pneumatic control, hydraulic control, computer control, biological control, economic control, etc. These are the different fields where we can apply control theory. Then we can have minimum phase system, minimum phase control, and non-minimum phase control, non-minimum phase system. So minimum phase system, that means there are no poles and zeros in the open loop transfer function in the right half. So if there are poles and zeros present in the right graph for the GSHS function, that is called non-minimum phase control. So these are the classifications. Then we have what is called method of analysis. So there are two methods employed. So methods of analysis and design. For a control system, you can analyze or design using two approaches. So one is called classical control theory. Classical control theory. Classical control theory. So which is a frequency domain approach. Frequency domain approach using transfer function. Here we are making use of transfer function using transfer functions. So one, we can make use of transfer functions. And second approach is modern control theory. Modern control theory. Or that is what is called state space approach. State space analysis. State space analysis. The difference between classical technique and modern technique, I told you. Classical control theory is applicable only for classical theory. Classical theory is used for the analysis and design of linear time invariant single input single output system. Single input single output systems. Modern control theory. Modern control theory can be employed for the analysis and design of linear, non-linear, time invariant, time varying, seesaw mechanisms or MIMO mechanisms. So that is the difference between classical theory and modern theory. But classical theory is applicable only for linear time invariant system. That is what is called LTI system, linear time invariant system. And modern control theory, I can use it for linear, non-linear, time invariant, time varying, seesaw, MIMO, etc. So these are the classifications of control systems and method of analysis and design. So now we come to open loop control. Open loop versus closed loop. Open loop versus closed loop systems. So if there is no connection or feedback, we call it as feedback. If there is no connection between the input and output, it is called open loop control. It is called an open loop system. For example, I will have a controller. So this is my controller and I will have a plant. So this is my controller and this is my plant. So this is my output. So I am not feeding back the output for control action. So this is open loop control. So open loop systems are less complex and less expensive. Open loop systems are less complex and less expensive. There is a definite relationship between the input and output, If there are no internal or external disturbances, if there are no internal or external disturbances or parameter variations, I can use open loop. If there are no internal or external disturbances or parameter variations, if there is a definite relation between output and input, if I want the system to be less complex and less expensive, I can use this. There is no stability problem. There is no stability problem. There is no stability problem in open loop system. In open loop system. So open loop systems are inherently stable. But what I require is occasional recalibration. Occasional or periodical recalibration of the system. Recalibration of the system is essential in maintaining the quality of the system, in maintaining the quality of the output. So that is very much essential, recalibration. For example, traffic signal, you have to occasionally study the traffic flow. Once in a while, you have to again study the traffic flow and accordingly control the time period. So these are time controlled mechanisms. These are time controlled mechanisms. Time controlled mechanisms. Open loop systems are time controlled. Time is set. Time controlled mechanisms. So if there is a calibration problem, if there are disturbances either externally or internally, if there are parameter variations of the plant, then definitely the quality of your open loop system will be poor. So in that case, I will go for a closed loop system. Upon the design of the plant, if the plant is not designed properly, if the plant or system is not designed properly, the output of the system will be different. The output varies. If the plant is not designed properly, the output varies. Plant design is very critical in open loop control. When we are using resistors, inductors, capacitors, we have to make use of resistors of very small variations. That means your tolerance of the resistor, inductor, capacitor, etc. should be very, very small. That is called parameter variations. As time elapses, as there is aging, your parameter may change. If the parameter changes, your output changes. So your quality of your output will be poor if there are parameter variations. That means if you can design the plant properly by proper components, by expensive components, your system may behave properly in open loop system. So these are the conditions under which we go for open loop systems. So open loop systems are found to be less expensive and less complex. Now we consider a closed loop system. So we have a controller. So normally this is the symbol adopted for this. We have various blocks in the system. So these are the minimum 3 blocks in a control system. So we are feeding back a part of the output to the input. So this, I call it as reference input, which is denoted by the letter RT, reference input. So let us put this plus minus, that is called a negative feedback, plus minus. And this signal is called a CT, controlled output. So this is called ET, error signal. So we can call it as an amplifier block. So normally we will have an amplifier, we have an actuator block, and we will have a plant. So this block is what I am going to control. This is my plant. And this is my feedback element, feedback system, feedback element. It can be a potentiometer, it can be a tacho generator, etc. So this is my feedback element. And this signal, I call it as BT, my feedback signal. So this is feedback signal. So I have a reference input RT, error signal ET, feedback signal BT, controlled signal CT, and I have various elements in the feed forward path. So this path is called feed forward path, and this is what is called feedback path and feed forward path. So this first block is an error detector. So our control is error detector plus amplifier, that is control, error detector. So error signal ET equal to RT minus BT. And my BT is a function of CT. Feedback signal BT is a function of controlled output CT. So I am feeding back a part of my output to the input for control action. So this is our feedback control. So this is block diagram of a feedback control. So block schematic of a feedback control. Block diagram of a closed loop control. So in closed loop control, we have a connection between output and input. So I can control my output by controlling a part of my output, and using this error signal I can correct the output error. So block diagram of a closed loop control. So in a closed loop control, using a feedback signal, the quality of the required output can be controlled. So I can maintain the quality is in feedback. It is complex and more expensive in many of the cases, not everywhere, and more expensive. The parameter variations and disturbances will not have any effect on the output quality. So output I can easily control even if there are disturbances or parameter variations. The plant design is not critical. Recalibration is not required. So these are the advantages of closed loop control. I can easily maintain the quality of the output, but it is going to be more expensive and more complex. But another problem is, so there is always a stability problem. There is a stability problem. Associated with closed loop control. Such a problem is not there in open loop system. So the major problem in closed loop method is a stability problem. So I have to analyze for stability. So examples of open loop system. Examples of open loop and closed loop controls. Open loop and closed loop controls. 1. Automatic washing machine. Automatic washing machine. Semi-automatic washing machine. Semi-automatic washing machine. So this is open loop system. കാരണം ഇവിടെ ടൈം പീരീഡ് ആണ് നമ്മൾ സെറ്റ് ചെയ്യുന്നത്. സോ ഓപ്പൺ ലൂപ്പ് സിസ്റ്റം. ട്രാഫിക് സിഗ്നൽ കൺട്രോളർ. Traffic signal controller. Traffic signal control. Here also we are setting the time period. So this is open loop. Bread toaster. So that is open loop. So we are setting the time period in bread toaster. Speed control of DC motor. Speed control of a DC motor. Voltage control of a generator or alternator. Voltage control of alternators. Frequency control of alternators. Frequency control of alternators, etc. ഇതൊക്കെ ക്ലോസ്ഡ് ലൂപ്പാണ്. സോ ദിസ് ഈസ് ക്ലോസ്ഡ് ലൂപ്പ്. ഓട്ടോമാറ്റിക് ക്ലോസ്ഡ് ലൂപ്പ് മെക്കാനിസംസ് ആണ്. ഓട്ടോമാറ്റിക് ഫീഡ്ബാക്ക് മെക്കാനിസം. ഓട്ടോമാറ്റിക് ഫീഡ്ബാക്ക് കൺട്രോൾ. ടെമ്പറേച്ചർ കൺട്രോൾ ഓഫ് എ റൂം ഹീറ്റിംഗ് സിസ്റ്റം. ടെമ്പറേച്ചർ കൺട്രോൾ ഓഫ് എ റൂം ഹീറ്റിംഗ് സിസ്റ്റം. ടെമ്പറേച്ചർ കൺട്രോൾ ഓഫ് റൂം ഹീറ്റിംഗ് സിസ്റ്റം വളരെ ചീപ്പറായിട്ട് നമുക്ക് ക്ലോസ്ഡ് ലൂപ്പ് എംപ്ലോയ് ചെയ്യാം. അപ്പോൾ ടെമ്പറേച്ചർ കൺട്രോൾ ഓഫ് എ റൂം ഹീറ്റിംഗ് സിസ്റ്റം, ദാറ്റ് ഈസ് ക്ലോസ്ഡ് ലൂപ്പ്. So that is automatic closed loop or automatic feedback. Air conditioning system. Air conditioning system. So that is closed loop. Closed loop. That is automatic feedback. So automatic feedback control. An autopilot mechanism. Autopilot mechanism. So that is an automatic feedback control. Automatic feedback control. So what is an autopilot mechanism is when you operate an aircraft. So the most critical operations of an aircraft are landing and takeoff. So during landing, we are using landing gears. So if the landing is not done properly at a particular point, if it overshoots the landing position, so there will be very severe problems, very severe accidents can occur, because many of the airports in the world are called tabletop type. That means below the airfield you will have hilly regions or you will have ditches, and the aircraft, if it overshoots, it falls into a ditch or it can break. So the location of the landing, the exact point where the aircraft should land, it is very important. So in order to land at a particular point or at a particular region safely, there should be proper visibility. But visibility is the major point for landing and takeoff. If the visibility is not poor, if it is a snowy region or snowy what is called time period, if it is heavily raining, then visibility may be very poor. If the visibility is not very poor, if it is not proper, the landing cannot be done properly. So normally what we do is we divert the plane to another airfield where visibility is proper. That is one alternative. Another alternative is to employ a computer control, which is an automatic control. So that is what you call autopilot. A computer will take the function of a human pilot. So that is what you call autopilot system. So during landing and takeoff, the two critical procedures are normally done by human beings, human operators. And human operators are better than computers. So normally we don't depend 100% on the computers for landing and takeoff. So other than takeoff and landing, if an aircraft is flying at a certain altitude, once it reaches a certain altitude, then pilot can relieve his operations and the function can be given to an autopilot. An autopilot can be used when the aircraft is at a certain altitude where there are no problems. So human control is handed over to a computer control. So that is called an autopilot system. So autopilot system is normally employed when an aircraft is flying at a certain altitude where there are no further problems expected. But normally during landing or takeoff, autopilot system is rarely used because we cannot depend on machines 100%. There can be problems with the machine. So pilots are normally employed for landing or takeoff. Exceptional cases only we take care of, or machines take care of landing and takeoff. Otherwise, if the visibility is not proper, so normally aircrafts will be directed to another airfield for landing or takeoff. So this is what is called autopilot system. Upon running time, we don't require any pilot. So an autopilot can take care of that. Because once the aircraft is at a certain altitude, for example 30,000 feet, then we don't expect much problems. So an autopilot can take care of control of the aircraft. So this is autopilot system. Autopilot is control of the aircraft by a computers. So that is an automatic control mechanisms. That is autopilot. So these are some of the examples of open loop systems and closed loop systems. And what are the advantages and disadvantages of each type of control.